Bonjour tout le monde. Oups. Je suis content qu'il y ait un micro parce que moi j'ai une voix qui ne porte pas très loin. Donc avant j'aimerais remercier Alejandra. Je ne sais pas où elle est, mais c'est vraiment elle qui s'est occupée de l'organisation de l'événement. Je pense qu'elle n'est pas là. Bon. Oui. Ensuite, OK. So I think I will do it in English because what I'll be presenting aujourd'hui, it's important for the campaign in 2019. So I want to make sure that all the participants understand where we are heading. So for ATRAPP, the way I see ATRAPP is that there are three big panels. So there is the collaborators, which are sampling. So they feed the project with a lot of samples. Then these samples are going through analysis. There are different types of analysis, but we have the cyanotoxin analysis, the nutrients analysis, and then the genomics analysis. And the third panel, I don't know. Okay. So today I will be presenting you an overview of the cyanotoxin analysis since the beginning of the project. So when we started the project in 2016, we had planned to do analysis of individual microsystems. Is there a power or laser? If I'm moving, okay, no. Faire avec ça. Well, no. No, it's okay. So we have the individual. Okay. Okay, it's better. So we have the individual microsystems. So at the beginning we had planned for 12 microsystems. We had other congeners in mind to be added, the cylindrospermopsin, the anatoxin and anatoxin variants, and this is called, we called MC individual. When I'm sending the samples, the results out, this is when we say MC individuals. So some of these methods were already done. And then we have the second method, which is the total microsystems, which is analysis by removing the ADA group. And this also was already set up. And then we had the third method, which was the BMA analysis, saxitoxin variants. And this was an ongoing development, and we work hard for this, developing the analysis of the BMA. And then we had also mentioned the lipopolysaccharides, and this was very vague. If it's possible, and if we can get it, we will do it, but we didn't get to work on that yet. Okay, so at the beginning, in summer 2017, we had a great team. We had Audrey, who worked so the project started in October 2016. So, yeah. So Audrey, she worked all the winter to introduce more microsystems into the method. She also added the homoanatoxin and anabienopeptide analysis on cyanopeptolene. And this is our schematic evolution, how this is happening in the lab. I know right now what I'm doing what Audrey did last year, so I hope I do as well as you. I'm trying to present this to the people. So we have, in the lab, when we have a sample which arrives, most of the time the sample is filtered, so we get the filter, where we measure the intracellular fraction, and the filtrate, where we measure the extracellular fraction. And in case where we get unfiltered sample, if we can do the filtration if the sample is not frozen, then we have the filter and the filtrate. Otherwise, we proceed with analysis in the unfiltrated sample. So every sample ends up by having 6 analyses, because the filter is analyzed for MC individuals, MC total, and BMAA. Same thing goes for the filtrate. So in 2017, the BMA method was not set up, so we put beside this in the fridge. We stored this for further analysis. So in 2017, we received 660 samples. So when I'm saying 660 samples, imagine a sample here, which ends up in our labs, in our freeze, like a lot of bottles. So we had to buy 2 fridges to be able to store everything and to do a later on analysis. In June 2017, when the big summer started, Marie-France came into the lab and she started doing the analysis. And by the winter of 2017, we realized that, in fact, we are quite late in handing the results. So we had somebody else, Noor, who came in the lab to help her. And we end up by finishing the results for the summer 2017 in May 2018. That's where we handed all the results. So the sampling campaign started in May and finished in November, and all the results were handed in May 2018. So now, summer 2018. So, here, okay. Okay, good. So I go back here because I have something to mention. So in 2017, when we analyzed the results, we realized that, in fact, a lot of samples were negative or didn't have cyanotoxin inside. So we did all this analysis for nothing. So we decided to change methodology, and we asked the people to send us the unfiltrated one and then the filter and the filtrate, because we don't want to do a lot of filtration in the lab. And then we analyze the unfiltrated sample, and if there is something, we go on and we do this analysis. MC individuals and MC totals on the filter, and the same thing on the filtrate. And this was supposed to be great, but back here. So now, summer 2018, we're getting ready for the summer. In 2017, the blooms were not really high. We didn't know, we knew what to expect for summer 2018. We are ready. And so we had Audrey, Marie-France, and Noor. And we knew by that time in June that Marie-France had to leave because she had to give birth to her baby Theo. So I already planned that. We hired Emmanuel, and we had Emmanuel and Audrey. And well, I'm here now, everything should be fine. We're ready to receive the samples. And then, no, not yet. And then in July 2017, Audrey, she got a position at Environment Canada, and she left. And I was like, oh, okay, I'm doing a lot of administrative stuff, but now I'll have to literally put work, I will have to fill your job until we find somebody else, and if I can help. And in the meantime, Emmanuel, she started having problems. The transport control wasn't working. We have a control reference material in the lab which wasn't giving us proper results. And then we stop everything. We say we order new standards. Then we realized that this method, that the MC total method, wasn't working properly because the percentage of oxidation was quite low. So there was no point in doing analysis. We stopped. And then Emmanuel, she got an offer at Health Canada to work in the cannabis analysis, and she left, so it's hard to compete with cannabis analysis. Pot analysis is not, it's much more sexy than cyanotoxin, and nothing was really working in the lab, and I was like, oh, okay, this is great. I really don't know how to do MS analysis, And this is a picture of me. It's my daughter who drew me at the end of the summer. She said, Mama, you're really a little bit freaking out. But anyway, things turned out okay because I asked for help. So I went to Sun and I say, Sun, you really got to help us, in the lab because I don't have experience. And then in the meantime, we also hired Tuk, which was really good. So this new team, they start working, they took all the problems one by one, and they start solving the problems. And while solving the problems, they also improved the protocol. We were handing in LODs and LOQs, which were measured at every standard curve, and they determine LODs and LOQs for the method. So we have like they are not fluctuating, they are not measured at every standard curve, which is good for you for when you do analysis. And this is the slide where I show, I'm not going to go through all these points, oops, but I show you like what are the changes. And here you have, here we have the old LODs, and that's the new one. And it shows that they are a little bit more sensitive. And this ended up by being a publication written by Audrey, which is good. And we also did, to test our methodology, we had a sample sent us by Barry, and we sent the sample to two different laboratories, and we saw that our measurements are in the same range as the other two laboratories. Of course, we don't have the same LODs as the other laboratories, and in the same time, we saw that our method for measurements of MC total, it's now working properly, so we knew we have to work on that before like analyzing the rest of the results. Okay, so today. So this week I did my last compilation. So I say good. Now we have all the MC individuals for the. I'm sorry, this should be here. For the filtrate, so for the extracellular fraction, which is analyzed. And the rest, nothing is analyzed yet. I know we received 1,300 samples in the lab, which tripled that in barrels. And then I found out this week, talking with Polytechnic, that they have another 400 samples in their fridge that they have to send, and they keep, because we don't have space. So actually, we are not done with all the MC individual analysis. And we also have another 200 samples which are coming from lake pools. So we are quite late behind. But good news is that Tuk and Sun and Gabrielle, they worked and they finished to find a way to analyze the BMAA. So we have this method which is ready. And we also have this method, MC total, which they set up, and they start already doing the analysis. One thing I forgot to mention is that when Tuk, he entered in position, and after they changed the method, he redid all the analysis of 2018. So the 2018 is done with a method which is more sensitive. So now I estimate at about maybe 2 months to finish all the analysis. That's being very, I hope if everything goes fine. So now, one thing I'd like to change for the campaign for 2019, and I'd like to mention, is that at the end of 2017, the EPA came out with a new protocol for analysis of anatoxin and cylindrospermopsin, and thanks to Barry, because Barry, he was the one who said, "Hey Dana, did you see the new protocol from EPA?" I'm like, no. But when I saw it, I say that would be good for us to implement it, because for analysis of anatoxin and cylindrospermopsin, we have to add an preservative. So what we'll do different for 2019, it will ask people to send us the filter and the filtrate for analysis of MC individuals. And when we're analyzing MC individuals, we automatically analyze anatoxin and cylindrospermopsin. So we'll do the analysis automatically with these samples. But in the same time, we'd like to have the new, the sample taking with the preservative, and we'll do the analysis for the MC individuals with the new, the sample which contains the preservative, and we'll see if there is a difference I suspect we'll probably analyze a higher quantity of anatoxin and cylindrospermepsin because we have added a preservative. Okay. So I'm going to present you. So I spent a couple of weeks of analyzing the results of all the results in the lab, and I'm not going to present you the graphs which did not work because I plotted a lot of cyanotoxin concentrations versus nutrients to see if we see a trend or if we see something which looks interesting. But with only the partial analysis that we have so far, it's hard to get a trend, and I didn't see something which was really interesting. But some things that I'd like to show to you, for example, is that this is the result of the high intensity sampling sites in 2018. So what I plotted here is the extra, the total, and the extra and the intra. And what we realize, in fact, is that the extra, it's a higher quantity than the intracellular. I was expecting something different. I was expecting a higher quantity for the intracellular versus the extracellular, but that's what we got for 2017, and that's under analysis. Then for 2018, I did the same thing, but because we didn't have the MC total, because the method wasn't working probably, I did the sum of the individuals, so all the individuals we measure. So I plotted the sum of the individuals, and the sum of the individuals in a lot of cases gives a good indication of the MC total, because most of it's what we, I don't want to go into that, but yeah, every sample is very different. But it gives me an idea of like the values we should get for 2018. And don't forget, these are log plots. So as you can see, the values are quite low. Last year, we only have one site which was very high, which is a site in France. And we had few sites which are in west of Canada, which were high, but the rest is quite low value. And the same trend is happening for 2018. So even though we get blooms, it seems like these blooms are not toxic. Now, so I know it's very small, but what I plotted here is the value of the anabinopeptins we got in 2017, all sites together, and 2018. What we measured in 2017 are the one in the orange box. So it seems like in 2018, we have measured much more, or in more sites, anabinopeptin A and B than in 2017. So that's an interesting result. We'll see what the rest of the other results is giving us. And I did the same exercise for anatoxin and cylindrospermepsin, and we get similar results. In 2017, which is here, and this orange box, these lines here is because we only get one measurement. I mean, only once we have measured something. And this box here is the values for 2017, and here is for 2018. And it looks the same thing. It looks like we measure in many more sites in 2018 than in 2017. So I'd like to just make, like, the conclusion I'm making is that, okay, cyanotoxin analysis for 2017, they are already done. They are handed to all the collaborators. We have cyanotoxin analysis for 2018, in my opinion, analyzed only 30%. But because the methods are finished or like up to date now, it should go faster, it should go well. We already started the analysis of MC total. As I mentioned before, we having anatoxin and cylindrospermepsin, which are analyzed in double because they are analyzed in the barrel with preservative and in the barrel without preservatives. And the idea to have it in the bottle without preservatives is to be able to compare with other years. And I guess, PMA analysis, now that that method it seems to work, will be set up, will start soon. And that's a big plus for the lab, because I think it's the first time that BMAA could be separated from the other variants, from the other 3 variants. And I'd like to mention that we have also more, so we have this team. Okay, now we have this team in the lab. And we also have 2 more people working, Martin, who's gonna come to help Tuk with the analysis, and also Alison, who's a stagiaire in our lab for the summer 2019. Okay. Thank you.
Thanks, Dana. Just I think you kind of explained this, but maybe just to clarify, do you think that the data from all the years will be comparable with the changing methods? And I know there's benchmarking, but like, what's the take-home message on that? Or is every year kind of analyzed separately?
But I think it could be comparable if we use proper statistical analysis, like I think it's the Hansel-Meyer analysis, which actually it was, again, Barry. Thanks, Barry, to making me aware of that, which is used in pharmaceutical companies where they have a lot of data which is undetected or borderline. So I think we should probably look into applying that type of statistical analysis to be able to compare the data from 2017 and 2018. And also because we have a lot of non-detected, or which are between LOD and LOQ, and we lose a lot of data because a lot of this is between these 2 values. So we should probably try to get use of this, at least in part, which is treating with analysis for the activity 1 with the water sources. I don't know if this could be applied to activity 2. I'm not very. I don't want to speculate in that, for the analysis for activity 2.
Okay, and if I can venture just one quick other question. You had ELISAs as an analysis that was going to be done as well. Is that right? Did I understand that?
Yeah, well.
But that haven't been done yet, right?
It hasn't been done, ELISA.
Okay.
But ELISA, it was just like a beside method, a backup method. And also, I think that the level of detection of ELISA, it's in the PPT, where we're much lower with MS. So
right. I guess I'm curious, because if they're easy to do, just to show, as a comparison, to show the increased sensitivity, or maybe this has already been established, but just it could be interesting, even if it's just to show that they're not very, they're not very sensitive, and that maybe there's false positives and so on. But if that, I don't know, if those analyses are interesting to do, even just to show that they're not very good or they have limitations.
But ELISA, it's already known that it's a method that is just applied, it's a method that is applied in the field at the first. It's easy to apply, so people use it, and then if they get something with ELISA, they go further and they do MS. But a lot of our samples are in such a low range that with ELISA they won't be detected at all. So, yes.
Just on adding on that is that just see at Poly we have some ELISAs. So the sample we do on oxidation. We actually run them on ELISAs, and then the sample will go to UdeM. So those samples will provide the opportunity to compare between the ELISA and the methods, that analytical methods. So, and we use higher toxin concentrations. So what just is looking, it will be directly done once the Polytechnic samples are analyzed in your labs.
Okay.
Because we have exactly the same samples run on ELISA.
Okay, but if it's the same samples run on ELISA, because if you run your sample as an ELISA and there are samples which have chlorine inside, I think there is
No, we quench before we analyze. So oxygen will be always quenched before we analyze.
Okay.
Yeah.
Okay, we can, of course, I mean, it's actually, we are talking about using ELISA to to back up. But as I say, most of our samples are in such a low range that ELISA.
No, I was just adding to Jesse's comments
Jesse.
that this what Jesse is asking is actually valid. It's a valid question, and we can do it indirectly with the samples that will come from
Sure.
Polytechnic.
Right.
One quick comment. The objective, I mean, there's been a lot of comparison between ELISA and MS, and most of them showed that at low concentration, there's a lot of false positives and false negatives. So we will do a comparison with some selected samples to have that data for ourselves, but we know what it's going to say. And the trick becomes really at the low detection range. Because at high concentration, there's high concentration, we see high concentration, doesn't matter. The trick that we're really trying to solve is how can we use and basically the detection limits for 2018 are going to be better than 17, and how can we do what's in between LOD and LOQ? We know it's there, but we don't know exactly how much is there. We can't put a number on it, but it's a valid information, and we need to figure the right way of using it.
Yeah.
We probably need to move on.
Sure. Sylvie, I think Sylvie, she had a
Ben, tout comme toi, j'étais surprise de voir qu'il y avait beaucoup plus d'extracellulaires. Est-ce que c'est expliqué? Est-ce que les fleurs d'eau que vous avez qui ont été échantillonnées étaient plus, en guillemets, beaucoup de cellules mortes? Il y était beaucoup de bleu. Est-ce que vous savez pourquoi? Parce que ça semblait pas, comment je pourrais dire, des données extrêmes. Ça semblait être une tendance qui était toujours plus élevée.
Oui. On ne sait pas exactement pourquoi parce que moi aussi j'étais surprise du résultat, mais on est en train d'essayer de trouver en laboratoire, d'essayer de répondre à cette question, pourquoi on détecte.
Un des bouts de la question, c'est aussi il y avait des questions sur l'oxydation de notre méthode MC Total, et donc peut-être qu'il y a une portion qui est analytique, mais ça, on est en train de le confirmer.
Moi aussi, Sylvie puis Arash ont présenté des résultats, restés jusqu'à 4 heures, pour montrer la différence. C'est frappant. Quasiment pas d'intracellulaire, sauf dans les bouts. Dans les bouts, on en voit. C'est que nous, on se pose la question. L'autre chose, c'est les résultats qui ont été présentés. On voit des différences, mais on est en dessous du microgramme tout le temps, parce que la méthode est très sensible. Donc, peut-être qu'on est habitué de voir dans les blooms où est-ce qu'on est à plus haut que ça, ne se produit pas à des niveaux plus bas. Ça, c'est vraiment intéressant. C'est qu'il peut y avoir des biais analytiques, mais ça peut être aussi une situation, comme tu dis, quand tu as juste une production très faible, presque, moi, du 100 nanogrammes, j'appelle ça du background quasiment, là. Mais est-ce que c'est complètement différent comme répartition par rapport à des blooms où tu as 1, 2, 3, 10, 15, 20, puis jusqu'à 100, nous autres, on a eu à Bedford. C'est que là, peut-être qu'à ce moment-là, la gestion, et puis il faut aussi penser qu'à ces niveaux-là, peut-être les erreurs analytiques totales versus dissus sont différentes aussi.
J'ai eu les mêmes commentaires quand j'ai présenté ça à Toronto puis en Europe, et je pense qu'il y a un bout de la réponse ce que nous, on a, c'est des blooms, c'est une évolution dans des lacs relativement propres avec des fois des blooms. Et le gros des données qu'on est habitué de voir dans la littérature, c'est des blooms dégueulasses où tout va. Et donc, on ne compare pas tout à fait des pommes avec des pommes. Vas-y.
J'ai déjà le micro. Merci, c'est vraiment une belle présentation. Je me demandais, moi, pourquoi, parce que j'aime beaucoup la toxine BMAA, et je me demandais pourquoi vous avez décidé de l'analyser et pourquoi vous avez de la difficulté, peut-être parce que c'est juste le début.
En fait, la difficulté avec le BMAA, c'est parce que c'était difficile de séparer de ces isomères. Elle sort en même temps que le BAMA, le AEG et le DAB. Donc là, ce qui a été fait et ce qui est nouveau et ce qui est assez bien, c'est que c'est, je pense, la première publication où on voit vraiment une belle séparation. Et donc...
Parfait. En chromatographie inverse.
Ouais.
Puis il y en a beaucoup... je n'ai pas beaucoup regardé dans les articles, mais pourquoi vous décidez de l'analyser? C'est une demande?
Pour aller vraiment vite, il y a des liens qui sont débattus avec Alzheimer et avec la démence précoce avec Parkinson. Donc, c'est une neurotoxine. Le lien à l'humain n'est pas très clair, mais que c'est une neurotoxine chez d'autres animaux est très clair. Donc,